So we got through the first page yesterday, is that correct, gang? And we started with this question right here. Who was my group that got this right yesterday? Nolan here and Dylan. Okay. What do we say the values were to this? Did we say negative 15, negative 17, negative 19? And we talked about the idea of kind of guessing and checking to get those values. Okay, and that was really, whoa, that's really bright. Wowzers. That's better. Negative 15, negative 17, negative 19, we said were the solutions. And we wanted to come back to find the solutions here after we've gotten through the lesson. So the one thing I was going to tell you here is this. I believe we had gotten through this geometric application, right? We took all those four angles, we added them up, and then we set that equal to what value? We added all four angles up, set them equal to what value? 360, okay? After I figured out my x value here for that, what did we do? What was our x value here in this example? X was 75 in that example yesterday. Right? Not very good, lefty, but I'll try. All right. The question here after I went through and did this said, hey, find the measure of each angle. What did we do after we figured out that the x value was 75? Showing hands. What did we do to find the measure of each angle? Emily?
We found the other intermediate.
So anywhere where we had next, we threw in what value? Anywhere we had next, we threw in a 75. And what were those angle measures? I believe one of them was 75, right?
Right.
One of them was 58. One was 110. And the last one was 117, right? And at the end of the hour yesterday, didn't we check those answers and say, oh, all of those values added up to what value? 360. So the idea that I had all these numbers here and they added up to 360 indicated to me that we probably did the problem correctly or incorrectly. Correctly. Okay. All right. So I cannot remember if we got through this problem. We did get through this last one here with you guys, right? We got through all of that there. Okay. So example 6 is what was left. Is that correct? Okay. So in example 6, this doesn't show up very well on my board, but what I'm going to do here quickly is this. I'm going to run over here, and the example that you have here, I'm going to show you this up here, and we'll kind of let it unfold. All the notes are already written for example 6, so I kind of want you just to listen to what it is that we're dealing with here. All right. I'm good. How are you? Nice. The robot said hi to me. Okay, I believe this is the problem you have up there. Is that correct? For your next example? Okay. In example 6, I believe it says the same thing. It's kind of small on your notes, but the notes say use a table to find the number of miles X you need to bike on Friday. So that the, what's this word up here again? Mean, or average number of miles biked per day is what? 5. Okay, you guys want the average to be 5 there, right? So I'm going to progress through this here real quickly. Guys, first thing that we want to do solution-wise here is to be able to understand the problem. And I believe you already have this printed in your notes, don't you? Okay, it says right here. How about a volunteer to read what we're trying to understand in this problem? So I want a volunteer to read that for me. Want it, CJ? The same thing that's in your notes, I think, if you can magnify your eyes to get that.
Understand the problem, you know how many miles you hiked Monday through Thursday. You were asked to find the number of miles you need to bike on Friday, so that the mean number of miles biked per day is 5.
Okay, so we want the average to be 5 miles, right? Okay. How many days am I going to bike if I go Monday through Friday? 5 days. So how many totals do I have to add up before I can divide by 5? You have to divide by 5. And we want the average to equal what value? 5. Okay. So we would add all these up right here. 3.5 plus 5.5 plus. Wednesday looked like a nice day to ride. Must have been raining or something that day. Can't ride or run in the rain, can we, Nolan? Oh, okay. Thursday you rode 5 miles. Friday we don't know how many miles to go, but we know we want to average 5 miles for the whole week, right, guys? Everybody agree there? Okay, so we're going to add all these up. We're going to divide this by what value? 5, and we want to set that equal to an average of what here? 5. So right here, gang. Oops, come on. Come on. Come on. There we go. 2 says make a plan. Use the definition of mean to write an equation that represents the problem, and then solve the equation. Well, you guys simply told me add all these up, divide by 5, and set it equal to how? What average do you want again?
5.
Right. You guys agree with the equation right here? Monday plus Tuesday plus Wednesday plus Thursday plus the amount we need to go on Friday has to equal what? Has to be a 5 mile average after you divide the total by the 5 days that you ride. Okay, so there's the equation. What do you think they're going to do with the 3.5, the 5.5, the 0, and the 5 up here first? Add them up. Let's see if they did that. Is that what they did? You guys are looking at it. What did they add up to? 14. Now I said this is like a grouping problem from example 3, right? In order to get rid of this 5 down here first, what are you going to have to multiply both sides by? 5. So you're going to have 14 plus x equals what? Well, they multiply by 5, multiply by 5. You've got 14 plus x is equal to 25 after you simplify, right? Okay, what are they going to finally do to get the number of miles you need to ride? Subtract how much? 14. Now what's your solution, kiddos? 11 miles. So, you need to ride 11 miles on Friday. Okay? Do you understand the progression through that problem? The progression there is all written down in your notes for example 6. Okay? How are you feeling about this stuff so far? Multi-step equation. Pretty good? Okay, I want to get into 1.2. I think there's a few problems that we should probably discuss together as a group. I don't want to spend all day talking. You know what I would really love to do? Give you a little bit of time to work on some stuff today. Does that sound like a fair deal? Okay. All right, so let's do this. I think example-wise, we've gotten through everything, but we need to go back to that front-loaded question. Is that correct? The one that we started out with. And I want to show you the process for this right here. I get that the answers are correct on that first one, so now I need to exit this. So I think we've gotten through, we didn't skip anything yesterday besides that front-loaded question. Is that correct, gang? We got through all of this here? Okay. How about this page? We were through this whole page right here, page 2, right? So why don't you guys head on back to page 1, and I want to show you how to work that front-loaded question. All right, so we began the lesson here by saying you have, or they say an odd integer can be represented by the expression what here, guys? Why the plus 2? In other words, we're saying if your first integer is n, if your first odd integer is n, I'm going to write this. Whoops. I'm going to let this be the first odd integer. And you don't want to write this down, okay? We looked at a problem that did 3 consecutive numbers, and we used x plus 1, and x plus 2. Why am I skipping n plus 1 this time? What kind of numbers are we using here? We're using just odds, right? So if I'm using just odd numbers, is 3 an odd number? What would be the next odd number after 3? How much more than 3 is 5? It's 2 more, right? So to represent the next odd number, you would have to skip up how much? 2. So if the first odd integer is n, the second odd integer would be represented by what expression, kiddos? I heard it. Somebody said it. Shout it out at me. N plus 2, right? How many consecutive odd integers are we talking about in this problem? 3 of them right here, right? Talking about 3 of them right here. How many expressions have I got for odd integers right now? So far only 2. So here's a question. To get to the third odd integer, what do you think the expression for the third odd integer would be, guys? Anybody have an idea what it would be? N plus how much? Why n plus 4, Tori?
N is like 3.
3?
2, 4 more makes 7.
Right, because 2 more would be 5, right? And then if n is still 3, we would have to get to 7. So how much more would you have to add to the 3 to express that? Well, 4. Suppose this went on to a 4th consecutive odd integer. What would you say? Instead of just being 3 odd integers, what if we said 4 consecutive odd integers? Your next one would be n plus what? 6. Okay? So we're going to take these 3 expressions right here, n plus 2, n plus 4, and add them up to get what value? What do we want to add up to? Negative 51. Okay, so let me downsize this a little bit. We'll do the work. We'll see if that matches what we've got here. Where is it at? Edit, select all, downsize. All right, let's do the work for this. So the first integer was represented by which variable here? N, plus the second integer. I'm sorry, second odd integer, which was n plus 2, plus the third odd integer, which was n plus 4. That's all going to add up or sum up to what value again? Negative 51. Okay. All right, well, how many n's are here to combine, kids? So you've got 3n plus 6 equals negative 51, right? This is just a 2-stepper after that, isn't it? So what are you going to do here? The n's negative 57. Okay, what's your negative 57 divided by 3 now? Close. Did you say 19 or 18? Oh, all right. Doesn't work very well. Ask my wife, she'll tell you. She's convinced it's selective. That's what they say. Right? Well, that must be pretty cool because you listen to me once in a while. All right. If n is negative 19 right here, how am I going to find my other 2 integers if they were n plus 2 and n plus 4? What would you plug in for your n value now, guys? Negative 19. So the first one's negative 19. What's n plus 2 going to equal? If it was 19 below 0 and it warmed up 2 degrees, what's your temperature? Negative 17. Oh my gosh. The next consecutive odd integer would be n plus 4. Again, if the temperature was negative 19 and it warmed up 4 degrees, where the heck are you? Smack me on the head with a 2x4, but how do these answers compare to what we discovered in a guess and check method? How do these answers compare with what we've got in a guess and check method? McDonald's, I'm loving it, right? It works. It works, right? Good, isn't it? Oh, that's exciting stuff right there. I can do a backflip right now. I won't. I have too many donuts this morning. I don't want to upset my tummy. Okay, notes wise, that's the notes. Okay. Questions about anything in your notes, first of all. Here's what I want to ask you. The assignment that you got, 1.2. Why don't you guys get into that? Some of you may have started, some of you may have not even opened it up on the computer yet, but my question might be, is there anything in that problem set that's due for Monday that you guys might want to question me right now? Some stuff that you saw in there like, whoa. I had a bunch of emails about stuff last night and said some things were kind of difficult. So is there anything you want to ask about? How many of you guys have started on that second one at least? How many of you would say I'm at least halfway through probably? I think there was 33 problems. Does that sound correct? On 7? Okay. Mrs. Olson, there's one problem in there that I thought was probably a really good one. Do you recall that number? 19. Why don't you guys get into your assignment quickly? And I'd like to kind of run up to 19 and talk about that one because I think that's a difficult one. And I'd kind of like to see if we can't talk our way through that right now. I'm going to go ahead and stop this recording right now and add it to the notes. Now, did I tell you guys where to go?